Great. Welcome. I know Arctic is not everybody's favorite subject, not like vector tiles. Yeah, but they don't know what they miss. Okay. Okay, today I'm going to talk about some Arctic stuff we're doing. I'm from Canada, so we care about Arctic. It's cold. We love it. So first, from SensorUp, I'm wearing two hats. One is I have a company called SensorUp. I'm a university professor. But talk about SensorUp. So SensorUp, we develop sensor web and IoT platforms. We implement the first OGC SensorThings API and some plug here. So tomorrow afternoon, I'm giving a presentation about Open IoT made easy. So please come. You shall come. Okay, yes. Thank you. We are leading several international IoT standards, including OGC and ITUT, and I'm actively participating in some ISO stuff. And we are a member of Eclipse and the open source OGC. And that's me. I'm a professor as well as an entrepreneur and the father of Noah. I have a 6-month-old son. Okay, so Arctic. So where are the wildfire? So I heard it's a big problem about wildfire in the Arctic. But here's a very typical Arctic web map. Okay, you find it very typical on some Arctic websites. Okay, so what's the problem of this? Projection. This crowd knows, right? Projection. But actually, it's very, very bad because the distribution very distorted. Okay, you're thinking, oh, so this fire and this fire must be very far apart. Actually, they are not. They are pretty close. Okay, because in the Web Mercator, it's highly distorted in the high latitude area. Right? It's a big problem in Canada. Okay? So Web Mercator projection, everybody's using it. It serves 80% of the population well. However, there are still people that live somewhere north. Okay? So such as Canadians or Swedish or a lot of people. So this doesn't apply. Excuse me. Alternatives. Of course, for this crowd, we can always develop our own stack, right? We can set it up and load data into it. So deploy our own web mapping stacks, right? Easy peasy. And open source servers support multiple projections, right? Okay. So what you need to do? And so you can set up your own stack. You can also use the OpenStreetMap, right? Data is free, so not a problem. So you can always load the data in from planet.osm, load into web mapping server, set up a cache, a proxy, right, and adjust the platform, and then use a Pro4j and to do a projection, and then do a client, right? Easy. No, it's not easy. Okay, so I'm going to show you a very my friend, it's a lot of work. Yeah? And especially if you only want to display some dots for the Arctic region, and you need to set up all these. Not a very smart idea. I'm showing you a very typical Arctic web map. Still, I record this online today. It's very typical, right? So how when you deploy the whole stack, and then you do need some expertise to make it fast and then make it responsive, right? This is very 1990s. But this is very, very typical for the application for polar regions. Okay. So, but the question is, why so many applications still use Web Mercator projection? Why? I argue that, first, Web Mercator project tools provide great user experience. It's just easy to use. 2 lines of code, you can plot some dots on the map. That's easy. And many easy-to-use API SDKs, right? A lot of tiles available with minimum response time. Unlike the previous application I showed you, it takes just a couple seconds for every interaction. Okay? Actually, it's really, you don't do that. So data available for across Arctic regions. So actually, for Arctic regions, even in Web Mercator, you do have the data available. So kind of, yeah, you can use it, but not a very good idea. So as a result, we have this project. It's called Arctic Web Map. So very simple idea. So what is Arctic Web Map? Oh, by the way, it's open source, right? So go to the GitHub page. And then 2 parts, very easy. One is tiles. So provide the tiles. However, the tiles are not in Web Mercator. They are for the Arctic projections. And we provide 6 different projections. So you can rotate. I'll show you later. And the second part is a plugin, a Leaflet plugin for the tiles. and some polar-specific functions, right? So when you plot something on the map, you can do that, and then you can load the shapefile or load the GeoJSON onto it. You can plot correctly. When you rotate as well, right? Some of the Arctic-specific functions. So that's Arctic web map. So this is one example. You can rotate. I just show you. You can rotate. And you can integrate with the typical tools, right? And APIs. So there's a community called Ranking Inlet. So you jump into Ranking Inlet. And then you can also rotate. Okay? So again, when you rotate it, our implementation is you use the center of the map and you rotate, using this as the center to rotate, rather than the whole polar region rotates. Yeah? So we think that's useful. And then, as you can see, we serve the tiles. And the tiles synchronize with OSM regularly. I can't remember what's the frequency right now, but it's pretty fast. And so it's it's a nice tool. We also found this is great for community engagement. So we are thinking to organize a mapathon in the northern communities. So for the high school kids, and they can digitize their own community. If you look at the OpenStreetMap quality in the northern community, actually it's pretty bad. So definitely, I think it's great for community engagement. Okay, and we found people start using it, and unfortunately, most of the languages, I couldn't understand the language. I don't know what's this language, but this is one example. They use our tiles and the library to do some interactive visualizations based on this. And actually, this is the other one. Any Russian here? No. So nobody can read this. But I think it's a Russian website. I think it's from the government, actually. Oh, by the way, they didn't put the attribution here. That's a very bad thing to do. Okay? Nothing here. Okay. But this is one application that uses our tiles. And sorry. The other one, actually, I just found it today. Somebody was hiking near North Pole. And he used our application to record his hiking path. So it's April 24th, right? Hopefully, he didn't stop there and never upload anything. But again, this is, for Arctic polar applications, you shall use this, okay? Projection, okay? Don't use Web Mercator. I'm going fast here. Okay. I'm also running out of my slides. But I'm a professor, I can talk. Arctic citizen sensor. So after we have these tiles for Arctic web map, okay, we're thinking, okay, what kind of application we can do? So one of the applications we do is we want to sensor up the Arctic, right? We empower the citizens in the northern communities so they can collect data. So this is something we are doing. So we are doing some, this is a open source hardware platform. And we have a light sensor, a dust sensor, and humidity and temperature sensors. And then this is very, very easy to use. And also a board over here. And then actually this board is called Linky One. So it's $49 US dollars. And it supports 2.5G GPRS communication, Bluetooth, Wi-Fi, and GPS. So very good value in case you are interested in IoT. And then the case actually costs more than everything together. This case costs $80. So we are giving this out to northern communities. So set it up is very easy. And there's a serial number at the back of the case. So you just need that number in order to set it up. And then working on a second version of sensor with the OEM. So it looks better. So this is one idea, when you receive a sensor, how to register. So you register device, you select your location. Okay, it's based on our Arctic web map. And then let's say my sensor is there. And then there is a serial number. You put it there. And you put your name, Steve Lin Summer Cabin number 2. And you don't want to go there in winter. And register a device. And then it becomes part of the sensor networks in Arctic citizen sensors, right, for example. And you click on it. And then you'll get your sensor readings in near real time. So like that. In this case, the sensor speaks Wi-Fi. And this is, have you heard a protocol called MQTT? So this is pushing through MQTT into this. And by the way, everything we've shown here is following the OGC SensorThings API. So it's OGC standard for IoT. Yeah, so this is what we have done for Arctic citizen sensors. Oh, I'm done. And I'm going to show you more demos. This is one. And the other one, so we also developed this application. It's called Arctic Sensor Web. So in this case, actually, we load the data from multiple sensor networks, actually the weather sensors from multiple countries, and then feed into this polar projection, and then into the OGC SensorThings API. Because one problem for Arctic application is if you don't do anything about Arctic, you do need the data from the pan-Arctic nations. Okay? If you only have a Canadian data, not very useful because actually these places are pretty close to each other. So for Arctic research, it's really important to have the data from different places. So in this case, for example, this is a platform. You go here, for example, typical Leaflet stuff. And then everything here also follow the OGC SensorThings API. And then you get your air temperature and this and that. And so it's one platform allow you to see the pan-Arctic data. So this is an Arctic Sensor Web platform. And so today I talk about 3 platforms, but the one on top of each other. The first one is the web map, Arctic web map, 6 different projections. So you can rotate like that. So basically rotate means you change the projection. Yeah? So you change this projection, 3575 to 3576. That's rotating. Okay, so it's very simple. And then the first one, Arctic Web Map. The second one, Arctic Sensor Web. So based on that and the OGC SensorThings API, so we can put the sensors on top of it. The third one is a Arctic citizen sensors. So empower the citizens. They can get a sensor and register easily. And we're thinking next step is we're giving to the high schools in the northern communities, right? So they can run the science class and they can really care about their own environment. Okay. Any questions? Yes. Yes, you. You're the only one.
Okay, so can you talk about the pipeline you use to generate your files in OSM,
OSM, the stack, the OpenStreetMap stack. Yeah, typical, actually.
But do you use like Mapnik or something?
Mapnik, yes. Yes. Mapnik, let me think. Yeah, Mapnik. And then there's a cache there. I think, I can't remember, sorry. But the typical OSM stack, and we synchronize, and we try to synchronize as fast as possible. But our limited university budget doesn't allow us to have a very kick-ass server. Yeah. And nobody update Arctic that often. Anything else? Nothing about sensors? If not, tomorrow afternoon, SensorThings API, I'll show you how to be a geospatial IoT expert in 10 minutes. Okay, so please show up. Thank you.